So an object's position as a function of time is written as r vector t equals parentheses alpha t cubed minus beta t parentheses I hat plus parentheses gamma t squared plus delta square root t parentheses j hat. Okay, we need to find the velocity vector of this object and the magnitude of the object's position at and the magnitude of the object's velocity at t equals 2. Okay, let's get through this. So, number one, how do we even start with this? First, we have to realize that this is in terms of I hat and j hat. I hat and j hat are component vectors of our r vector. So what is a component vector? Let's do a graph, right? Say this is r. Essentially, you can project this and this. You can project r onto the x and y axis. So like that, right? So that's rx, ry, right? And these are also can be rewritten as I hat and j hat. I hat essentially means the x component of this vector, j hat means the y component of this vector. It's always the same. It's always I hat, j hat, always are x and y. Okay? Now, we need to find the velocity. Rishi, how the fuck do you find the velocity? Well, velocity is is the change in position with respect to time. What else is change in something with respect to something? That's right, a derivative. So what you do is you just take the derivative of each of these components, and there you get the velocity vector, right? So let's take the derivative. At cubed, derivative of at cubed is the power rule, which is ax n equals nax n minus 1. So a is our alpha here, right? So we do 3, bring that down, 3 times alpha t squared n minus 1, 3 minus 1 is 2, minus b, our beta, this is constant times a variable, derivative of that is just a constant, so we just put beta here. And then that whole thing is our x vector component plus 2 gamma t, same thing, bring the 2 there. 2 minus 1 is 1, so we don't need to write that there. And then here's where it gets kind of tricky. So right now we have delta square root t. I need you to understand something. Square root x, square root any variable, if you're deriving it, it's just the power rule in disguise, right? So a square root t can also be written as t to the power of 1/2, right? So if we want to take the derivative of this, we just convert it to t to the power of 1/2 and then derive it from there, because then we can just use the power rule, super easy, right? So bring 1/2 down, and then t, and then n minus 1, so 1/2 minus 1 equals 1/2 minus 2/2 equaling negative 1/2, right? So that's just what we plug in here. Negative 1/2t 1/2t times the power of negative 1/2, right? So it's delta times 1/2t to the power of negative 1/2, right? Now we've got the vector for velocity, right? We're done with that problem. Now we have to find the magnitude at t equals 2. You can't just add these together because then you're missing out on the direction, right? So remember how these both are components of this? If we just changed r for v, right? If we just change r for v, this same deal, right? So we can literally just take this and translate it there. And so now we have what, ry there. What does that look like? It's a right triangle, meaning we can use Pythagorean theorem to find the magnitude of our velocity vector, right? So now all you need to do is just, first of all, you want to plug in t here, right? Go ahead and plug in all your numbers, and then you should get 4.8 squared plus negative 2.988 squared equals velocity at t equals 2, meaning velocity at t equals 2 equals 5.66.
I worked for 5 minutes, so it's time to take